Hello everyone. Today we'll be talking about the multiplication of the vectors as well as we'll talk about the division of vectors. In physics, many times we encounter these situations where we see the multiplication of magnitudes of two vectors and some trigonometric function, sine or cosine. So based on these two possibilities, we have two types of the products of the vectors. Number one, scalar product or dot product, and the number two is the vector product or cross product. And at the end of the video, we will talk about the division of the vectors. So as usual, take out your notebook and pen and start making your notes. We will start this lecture with the dot product or scalar product. Suppose we have two vectors, namely A vector and B vector, and angle between these two vectors is taken as theta. Then their dot product is written as A vector dot B vector. Pay attention to the pronunciation, how you will read it. A vector dot B vector, okay, is equal to the magnitude of A vector, magnitude of B vector, and cos theta. The same thing can be written as AB cos theta like this, or A multiplied with the B cos theta, or B multiplied with the A cos theta. These are the important parts of the formulas which we should learn. It will ease our later on calculations. Let's talk about few important points. For example, in chapter work energy power, you will see the work done by a constant force is equal to F vector dot S vector, and which will be written as Fs cos theta. Here F is some constant force and S vector is the displacement of the point of application of force. Okay. In chapter work energy power, we will talk about the instantaneous power. The instantaneous power will be equal to F vector dot V vector. F is the force and this V vector is indicating the instantaneous velocity. Getting it? So in physics, we'll be requiring this a lot. This entire part will be required starting from the chapter work energy power. Till then, you won't generally require this thing. Okay, few important points. Number one, this dot product, if we look at the RHS, the result is scalar or vector? What you can say? The result is always scalar, because A is magnitude of A vector, B is the magnitude of B vector, cos theta will give you some number only. Okay. So the result of this product, this kind of dot product, is always a scalar quantity. That's why we know it as scalar product also. Second important thing, the result may be positive, negative, or zero, because the value of cos theta can be positive, can be negative, or can be zero in different situations. This is magnitude of A vector, and magnitude of a vector is always non-negative. This is magnitude of B vector, that is always non-negative. This term can attain either negative sign or positive sign, or it can become zero. Let us illustrate it. Suppose two vectors are perpendicular to each other, A vector and B vector. How much will be the dot product according to this formula? If theta is equal to 90 degree, it indicates that A vector dot B vector will be equal to AB cos 90 degree, and everyone knows cos 90 degree is 0. So in this situation, A vector dot B vector will be equal to 0, and it's a good trick. Whenever two vectors are perpendicular to each other, their dot product will be 0, or vice versa. If the dot product of two vectors is 0, it means they are perpendicular to each other. In few questions, we'll be using that trick. Okay. Another thing, dot product is positive. Suppose in between the vector A and B, we choose the angle theta in such a manner that theta lies in the limits 0 to 90 degree. Okay, here I am putting the equality also. For such case, the A vector dot B vector will always be positive. Why? You can check it yourself. Suppose you take angle theta is equal to 0 degree. Cos 0 degree will become 1. This quantity is non-negative as well as this is also non-negative. So your result will become positive. Suppose you consider the theta to be 30 degree. Then cos 30 degree will result into some positive thing. Understand? Root 3 by 2. This is also non-negative. This is also non-negative. So the ultimate answer will be positive. It means whenever the angle between two vectors is acute, then their dot product will always result into a positive answer. Done? Okay. Now you can think about another scenario. Suppose this is A vector and this is your B vector, and angle between them is chosen in such a way that theta is greater than 90 degree and less than equal to 180 degree. In this case, the value of cos theta will become negative. It means here A vector dot B vector will always result into a negative value. This is also important one. Getting it? Okay, let me ask you one question. In which scenario this will result into the maximum value? For which value of theta you will get this resultant as maximum? Can you tell? Correct. When theta is 0 degree. So that also we can write here. Theta is equal to 0 degree means what? The two vectors are directed along the same line. Getting it? Okay. Next important point. A vector dot B vector is independent of the choice of the coordinate axis. Next important point. The A vector dot B vector is commutative. What does it mean? We can say that A vector dot B vector is technically equal to B vector dot A vector. Why so? If you check the angle between A vector and B vector, that angle is theta. And the angle between B vector and A vector is also theta. So the answer will always be same. Getting it? You should note down up to here, then we'll be taking up few more important points. The next important point, the dot product is distributive. It means A vector dot B vector plus C vector can be written as A vector dot B vector plus A vector dot C vector. It's a simple statement. Next thing, the self dot product means A vector dot A vector. If we do, then it will be A cos 0 degree, because these two vectors are in the same direction, they have the same magnitude. So it is equal to A square. It is important in physics. Many times, if you see a term like this, it can be eventually written as self dot product. Next, suppose I ask you I cap dot I cap. We know that I cap is a unit vector along x-axis. Can you tell me the result? Looking at this formula, let's say this is A vector, this is B vector. So according to this formula, magnitude of A vector is 1. Then magnitude of B vector is also 1. And angle between these two vectors is 0 degree. Cos 0 degree is also 1. So I cap dot I cap will be 1. Pretty important result in physics. And we have I cap dot I cap, J cap dot J cap is equal to K cap dot K cap. this will always be equal to 1. It's super important. You should learn it. Okay. Another thing. Suppose if I ask you I cap dot j cap, what should be your answer? Looking at this formula, magnitude of first vector is 1, magnitude of the second vector is also 1. I cap is a unit vector along x-axis, then j cap is a unit vector along the y-axis. What is angle in between these two unit vectors? Correct, 90 degree. It means we should put here cos 90 degree. Cos 90 degree we know is 0. Getting it? And on the previous screen we had the talk, whenever two vectors are perpendicular, how much is their dot product? It's 0. So another important thing we can include here, that I cap dot j cap or j cap dot k cap or k cap dot I cap, this all will be equal to 0. Okay, you can write them in the reverse manner also, j cap dot I cap, k cap dot j cap, I cap dot k cap. All these results will always be 0 because I cap, j cap and k cap, these three unit vectors are always mutually perpendicular. Done? Next important thing, the projection of b vector along a vector is b vector dot a cap and then again a cap. Let's see the meaning of this thing. If you need the projection of b vector, then you go to the head of the b vector, and from the head of b vector you drop a perpendicular here like this. Projection of b vector is required along a vector. So from the head of b vector we are dropping a perpendicular like this. Do you agree? Then you obtain this length. This much length we know, b cos theta. So the projection has this much magnitude and the direction will be in the direction of a cap. Getting it? Similarly, if someone asks you the projection of a vector along b vector, then this formula will be written as a vector dot b cap and then again b cap. How we will simplify that? You extend the line of action of b vector from the head of a vector, because now you need the projection of a vector. You will drop a perpendicular like this here. Okay, then you will get this length. This length will be equal to what? A cos theta. Do you agree? So this projection of a vector along b vector has this much magnitude, a cos theta, and its direction is along the b cap. Getting my point? Another important point, if someone asks you the magnitude of these projections or the length of projection of a vector along the b vector, then its answer will be a vector dot b cap. Let us simplify this. You'll understand it very easily. A vector dot b vector divided by magnitude of b vector. Do you agree? This is the value of b cap. A vector dot b vector we already know is equal to what? ab cos theta, and the magnitude of b vector can be simply written as b. So this b and b is getting cancelled out. We are left with a cos theta. So that a cos theta is the length of projection of a vector along the b vector. Getting it? You can pause here and you can think about it carefully. It's actually easy. And the last important thing, the length of projection of b vector along A vector is, can you speak up the formula now? B vector dot A cap. Okay, and when you will simplify it, what you will get? You will get B cos theta. I am explaining that here. This is B vector. Its length of projection is required. So that length of projection will come out to be B cos theta. On the next screen, we'll be observing few more important things, and then we'll take ample amount of questions. Next important result. From this formula, if you want to obtain the value of theta, it will be equal to what? Cos inverse of A vector dot B vector divided by the magnitude of A vector and the magnitude of B vector. Remember what is theta? Theta is the angle between A vector and B vector. Okay. Sometimes we have the situations where we need to determine the angle between two straight lines, and in three-dimensional space the situation is complex. I'll be taking up few questions to illustrate that. Then this formula will be super handy. Note it down. We'll take examples on that. Next important point. If we have A vector is equal to AXI cap plus AYJ cap plus AZ K cap. B vector is equal to BXI cap, BYJ cap plus BZ K cap. Then how to obtain the value of A vector dot B vector? This is important. In many calculations, we'll be using this. A vector dot B vector will be actually equal to AX BX plus AY BY plus AZ BZ. Let us see the calculations detail. If you multiply this component with this component, then I cap dot I cap, you remember I cap dot I cap will become 1. You are left with AX BX. Then this component will get multiplied here with this as well as with this. I cap dot J cap will become 0. I cap dot K cap will also become 0. So no need of writing them. Then take the second component of A vector. It will get multiplied with this, and will this. Okay. So AY cap dot BX I cap, AY cap dot BX I cap, J cap dot I cap. J cap and I cap are two perpendicular unit vectors, so their dot product will become 0. Then multiplying these two components, AY cap dot BY J cap, so J cap dot J cap will become 1. You are left with AY BY. Then AY cap dot BZ K cap, J cap dot K cap, J cap dot K cap, perpendicular vectors. So that result will be 0. Now the last component of A vector will get multiplied with this as well as with this as well as with this. K cap dot I cap, if you do this thing, it will be 0. K cap dot J cap will also be 0. K cap dot K cap will become 1. So the remaining result here will be AZ BZ. Okay. I am taking one example so you'll understand it better. For example, suppose we have A vector is equal to 2I cap minus 3J cap plus 4K cap. We have B vector is equal to 7I cap plus 6J cap minus 2K cap. And we require the value of A vector dot B vector. You can pause the video here and you can give it a try based on this calculation. Although calculation is pretty simple, you have to just multiply these two numbers. 7 into 2 will make it 14. I cap dot I cap will become 1. Here j cap dot j cap will become 1 and 6 into minus 3 will make it minus 18. K cap dot k cap will again become 1 and 4 into minus 2 minus 8. Getting this result? Okay, you can simplify here and then you see the final result is just a number. There is no direction involved. That's why we call it scalar product. Okay. Now suppose in this example, someone asks you what is the angle between A vector and B vector. You know these vectors are in the three-dimensional space. Some vector might be directed here, some might be directed here. Visualizing them will be very tough. Finding that angle will be very tough. But if you know this formula, the calculation can be done pretty easily. How? Suppose we need the angle between A vector and B vector. That angle is given as theta. Theta is cos inverse of A vector dot B vector. A vector dot B vector we have already obtained. It is equal to what? Minus 12. Then we need magnitude of A vector. Magnitude of A vector, we know the formula. How to write the magnitude of A vector? I cap coefficient square, so 2 square plus j cap coefficient square minus 3 square plus k cap coefficient square means 4 square. Then you need the magnitude of B vector. So let's make some space here. For the magnitude of B vector, you should repeat it. I cap coefficient square plus j cap coefficient square plus k cap coefficient square. Getting the idea? These two vectors are in the three-dimensional space and using this formula we can easily obtain the angle between these two vectors. You can simplify the remaining calculation. Done? Okay. Here is a simple question for practice. We have two vectors, A vector and B vector, and we have to find the value of n in such way that A vector becomes perpendicular to the B vector. Visualizing these two vectors in the three-dimensional space and thinking about them will be typical. Will be directly using the formulas. Whenever two vectors are perpendicular, what is the condition? Correct. Their dot product becomes 0. So starting the solution part here, we know that if A vector is perpendicular to B vector, their dot product will become 0. Okay. Let us work upon the dot product then. We know how to simplify the dot product. A vector is given as 4i cap plus n j cap minus k cap. B vector is given as 2i cap plus j cap minus k cap. Do you agree? This can be written as 1 j cap, and here also you can write 1 for simplicity. We need A vector dot B vector. A vector dot B vector. 4 into 2 will give you 8. I cap dot I cap is 1. J cap dot J cap is 1 and n into 1 is n. Minus 1 into minus 1 will result into plus 1 and k cap dot k cap will be 1. This should be equal to 0, because if these two vectors are perpendicular, then their dot product must be 0. Let us simplify this thing. On simplifying this, n comes out to be minus 9. You can note it down. Then we'll go to the next example. Here is the second question. We have two vectors, A vector and B vector, and this angle is given as 120 degree. We have to find the value of A vector dot B vector. You can pause here and you can give it a try. It's a simple one, formula based. I am solving it on the board. Can you tell which formula we will be using? Correct. A vector dot B vector is equal to magnitude of A vector, magnitude of B vector, and then cos theta. Here theta is the angle between two vectors. Keep that in mind. Okay. So let us put up the values. Speak up. What is the magnitude of A vector? 8. Magnitude of B vector is 6. And cos theta, what we should write here? It's simple for you. It should be 60 degree. This part is important. Theta is the angle between A vector and B vector. And you remember how to take the angle between two vectors? Previous videos. In order to take the angle between two vectors, either their heads must meet or their tails must meet at a common point. So what we will be doing, we'll be shifting that A vector here. Earlier, let's say A vector was here and then you shift it here. B vector was lying at its own place. Earlier, this angle was 120 degree. Now the two tails are meeting here. So this angle will be useful for us. Getting it? Calculation is pretty simple. 48 into 1 by 2. So the answer comes out to be 24. Done? Here is the next question. We are having a cube and each side of the cube has the length equal to small a. Then we need to answer these 4 questions. Okay? It's a nice one. I'll be solving everything on the board. You just pay attention. For starting the solutions, first let us write the coordinates of few points which are required in the question, such as you require the point E, point D, point B. So first of all, I am writing the coordinates of point B. You can see the point B is lying in the XY plane. Its coordinate are A, comma 0. Do you agree? Its X coordinate is A as well as the Y coordinate is also A. Z coordinate is 0 because it is lying in the XY plane. Then you will require the point E also. The point E here is in the 3 dimension. You can check yourself. From origin, you go by a distance A along x-axis, you go by a distance A along y-axis, and then along z-axis, you come by a distance A again. So the point E has the coordinates A, A. Then you'll require the coordinates of point A. The coordinates of point A are simple. Point A is lying on the x-axis itself. So its y and z coordinate will be 0. Do you agree? Then you will require any other coordinate. E has been done, B has been done, A has been done, D. This is also simple. The point D is lying actually in the YZ plane. If you look carefully, it means the X coordinate of point D is 0. Its Y coordinate is A as well as the Z coordinate is also A. Done? Now, we will be requiring all such vectors. So, let us write them one by one. The OE vector will be written as the position vector of E, which is equal to AI cap plus AJ cap plus AK cap minus 0 I cap plus 0 J cap plus 0 K cap. I am explaining this again. If you need a vector which is directed from O to E, then what you should be doing? You should take the position vector of the point E, which is equal to AI cap plus AJ cap plus AK cap. Then you should subtract the position vector of the origin, which is equal to 0 I cap plus 0 J cap plus 0 K cap. So this is equal to AI cap plus AJ cap plus AK cap. Do you agree? Okay. So first you need to put here the position vector of the D vector. For D vector, what you will write? 0 I cap plus AJ cap plus AK cap. Do you agree? Then you should write the position vector of B vector. Speak up. AI cap plus AJ cap plus 0 K cap. Done? this a j cap and this minus a j cap will get cancelled out. So we are left with minus a I cap plus a k cap. Okay. So a to b vector, if you want to write, speak up. First you should write the position vector of the point B, which is equal to a I cap plus a j cap plus 0 k cap minus. Then the position vector of A, which is equal to a I cap plus 0 j cap plus 0 k cap. This a I cap and this a I cap is getting cancelled out. So we are left with a j cap. These many vectors we require for all such calculations. Now I am starting the first part of the calculation. It means cos inverse of which two vectors are involved? OE vector dot BD vector divided by the magnitude of OE vector and the magnitude of BD vector. Do you agree? So let's do that dot product individually. Here OE vector I am writing, which is equal to a I cap plus a j cap plus a k cap. The BD vector is equal to what? Minus a I cap plus 0 j cap plus a k cap. Do you agree? Now we need the dot product and we know the method. OE vector dot BD vector will be equal to what? I cap dot I cap will become 1 and a into minus a will result into minus a square. J cap dot j cap is 1, but 0 into a will result into 0 here. No need of writing that step. K cap dot k cap is 1 and a into a will result into a square. See one interesting thing. This entire computation is coming out to be 0. It means this is resulting into cos inverse of 0, because 0 upon some non-zero magnitude, final result will be 0. Cos inverse 0 means what should be the theta? Correct. It should be equal to 90 degree. If theta is 90 degree, you can deduce one important thing, that OE vector is actually perpendicular to the BD vector. Now, by looking at this diagram, can you get that insight that OE vector is perpendicular to the BD vector? Think about it. Is it easy? No. Visualizing in the 3 dimension of such vectors will be pretty complicated, but using the equations we can get the quick answers. Okay? You note down the solution to the first part, then we'll go for the second part again. Or if you wish, you can pause and you can also try yourself now the second part. For second part, we need the angle between OE vector and AB vector. How the AB vector will be directed? It will be directed from A to B like this. This is AB vector. OE vector is directed as shown here. Done. So let's go with the calculations. We actually need cos inverse of OE vector dot AB vector divided by magnitude of OE vector, magnitude of AB vector. For this computation, we can individually calculate OE vector dot AB vector here. OE vector can be written as AI cap plus AJ cap plus AK cap. The AB vector is written as AJ cap. Let's say we do the dot product here. Can you speak up the result? You know it very well how to compute such things. I cap dot I cap is 1, but A into 0 is 0, so writing 0 here. J cap dot J cap is 1, A into A is A square. A into 0 is 0, k cap dot k cap is 1, so ultimate result here is 0. It means this final answer will be equal to a square. So we got one part. Now you need the magnitude of OE vector. That also we need to calculate here. Magnitude of OE vector will be equal to what? Root of I cap coefficient square plus j cap coefficient square plus k cap coefficient square, which is equal to root 3a. And magnitude of AB vector is easily available here only. The magnitude here is A. So now we have all the data available. I am submitting the data here. It is cos inverse of OE vector dot AB vector is resulting into A square divided by magnitude of OE vector is root 3a and magnitude of AB vector is A only. Getting it? So what is the remaining answer? Cos inverse of 1 by root 3. That's your final answer. See, these two vectors are in 3 dimensions, OE vector and AB vector. Directly, if you want to visualize the angle in between them, it's pretty complicated. But using these formulas, we can compute the angles. Done? Similar pattern questions you'll find in the checkpoint. Those questions you can try yourself. I'll be solving the remaining 2 parts now. You note down up to here. Then we'll go for the 3rd and the 4th part. Let us start the 3rd part. We need the projection of OE vector along AB vector. Do you remember the formula? It will be written as OE vector dot AB cap and then again multiply with AB cap. Formulas we have already seen, so we need to put up the data only. In this computation will require the AB cap, so that I am computing here. AB cap is actually AB vector divided by the magnitude of AB vector. Do you agree? AB vector is already available. AJ cap divided by the magnitude of AB vector is A, so it is actually equal to J cap only. Actually, this result is evident from the diagram also. AB vector is directed along the y-axis and along the y-axis the unit vector is J cap only. Getting it? Now I am obtaining this part, OE vector dot AB cap. So first let us write the OE vector, which is AI cap plus AJ cap plus AK cap. Then I am writing here AB cap, which is equal to 0 I cap plus 1 J cap. AB cap is 1 J cap plus 0 K cap. We need their dot product, OE vector dot AB cap. Can you speak up the answer? I cap dot I cap is 1, but A dot 0, A into 0 will result into 0 plus J cap dot J cap is 1, A into 1 is A into 0 is 0, so writing the 0 here, although here K cap dot K cap was 1, but 0 into 1 will result into 0. So ultimately this is equal to A. Getting it? Now we are done with the things. OE vector dot AB cap is equal to A and AB cap is what? J cap. So this is your answer. The projection of OE vector along AB vector is AJ cap. Can you obtain this answer without all this computation? You can. AB vector is directed along J axis, Y axis. Do you agree? And along the j-axis or y-axis, along the j-cap or y-axis, what is the component? What is the projection of OE vector? Think about it. Compare them. Okay, let me ask you another question. If I ask you, what is the component of projection of OE vector along x-axis? Without any computation, you can say directly, this is the projection or the component of OE vector along the x-axis. This is the component of OE vector along the z-axis. And this is the component of OE vector along the y-axis. Clear? Just you people become familiar with the calculations. So I have proved all these things. Otherwise, the answers are already lying here. Okay. Now I can compute the fourth part very easily. They are asking the length of the projection. So if you know the projection, you already know the length of the projection also. This magnitude only we require. Length of projection of OE vector along AB vector is A. Done. It's a brilliant question. You should note it down, and then on the next screen you'll be getting a checkpoint. You should pause there and you should try each and every question for the better conceptual understanding. Okay. Now we'll be starting the most important part of this video, the cross product or vector product. Why the name is vector product? Because here the resultant answer is also a vector. Okay. In physics, many quantities are vector and this vector product is used extensively. So if you understand it very well, half of the physics is over. And one more important thing, if you don't understand this, even then half of the physics is over. So let us start the learning. Suppose you have A vector and B vector in a plane as shown here. The angle between A vector and B vector is theta. Okay. And the formula says that A vector cross B vector is equal to magnitude of A vector, magnitude of B vector, sine theta n cap. I'll explain the details of all parts. What is mod of A vector here? Mod of A vector actually means the magnitude of A vector, and it can be simply written as A only. What is mod of B vector? It is the magnitude of B vector. We'll write it B only. What is theta? Theta is the angle between A vector and B vector. Okay. What is n cap? It is most important among all. N cap is a unit vector which is perpendicular to the plane containing A vector and B vector. Suppose this is a plane. In this plane we have both A vector and B vector. Okay. Then n cap will be perpendicular to this plane, means n cap is like this. N cap creates an angle of 90 degree with the B vector, as well as this n cap creates an angle of 90 degree with the A vector. Since N cap is a vector, so this resultant answer is also a vector. That's why we call it vector product. In order to determine the direction of n cap, we use the right hand rule. That is super important. You need to pay attention here, and those people who are lefty, they should take extra precaution in this rule. You must always use the right hand only. Now, how to use this rule? Suppose you want the direction of the resultant of A vector cross B vector. Okay, then you stretch your right hand fingers along A vector and then they must curl toward the B vector. I am showing it here on my palm. This blue is the A vector, the red is the B vector. Okay, so this is A vector, this is B vector. Let's say my palm is the plane in which these two vectors are lying. I hope you can see both the vectors. Angle between these two vectors is theta. Okay. Now, in order to determine the direction of A vector cross B vector, you stretch your right hand fingers along A vector. This is my right hand and I am stretching the right hand fingers along A vector, the blue one. And then those fingers must curl toward B vector. B vector is the red marker. So stretching right hand fingers along A vector, curling them toward B vector, where your right hand thumb is pointing upward. So that is the direction of n cap. And you can see this upward n cap is perpendicular to A vector as well as perpendicular to B vector. Getting my point? Okay. Suppose someone asks you the direction of B vector cross A vector, then what you will do? You will stretch your right hand fingers along B vector and then they should curl toward A vector. I am stretching my right hand fingers toward the B vector, the red one, and then curling them toward the blue, means A vector. So B vector cross A vector, thumb will point in the downward direction. Okay. Few students might put the palm in the wrong orientation. They will get the issues automatically. See, suppose I want to determine A vector cross B vector and I put my right hand palm like this. The fingers are along the blue vector, the A vector. Now you think yourself that can fingers naturally curl toward B vector? I am talking about the curling of fingers, all fingers, not the hand. Okay, not the entire palm. If you put your right hand fingers along the blue vector, along the A vectors, can your fingers naturally curl toward the B vector, the red one? For normal people, it's not possible. It means this orientation of palm is wrong. Someone puts the palm like this along the A vector, the blue vector, and then you want to curl your right hand fingers along B vector. Can your fingers naturally curl? You are curling your palm, you are rotating your hand. Only your fingers must curl. So the correct orientation is this only. If you stretch your right hand fingers like this along A, now they can naturally curl toward B vector. Thumb will point towards the n cap. Getting my point? For B cross A, I am taking few wrong orientations. Suppose my palm is placed like this and the fingers are toward the red vector, the B vector. Now can these right hand fingers naturally curl toward A vector? Entire palm is rotating. Only your fingers must curl toward A vector. Is it feasible in this orientation for normal people? Not possible. The fingers cannot automatically curl toward the blue vector if they are placed toward the red one in this orientation. It means you cannot obtain the direction of B vector cross A vector like this. Getting it? Another wrong orientation of the hand. Suppose you put your right hand fingers along the B vector like this. Right hand fingers along the red B vector like this. Now if you curl your right hand fingers toward blue vector, is it possible? Only right hand fingers must automatically curl. Again, for normal people it's not possible. Getting it? So the correct orientation, only one orientation is correct for doing B cross A, that is this. Stretch your right hand fingers along B vector. Now your fingers can naturally curl toward A vector. Thumb will automatically point toward the n cap. Getting it? Okay, so this sense of direction is super important. So I'm making few questions. Here is the north, south, west and east. The directions are shown in the plane of the board, and that upward direction is coming out perpendicular to the board, which I am showing as a dot, and the downward direction is going into the plane of the board, perpendicular to the plane of board and inwards. So this cross is indicating the downward direction. Suppose I make a question, you try to answer it. Up, cross, east. Give it a try. Stretch your right hand fingers along upward direction, and then the right hand fingers must curl toward the east. Give it a try. Do not use the left hand, use the right hand only. I am doing that. Up is here outwards like this. Okay, so this is my right hand. I'll stretch the right hand fingers along the upward direction, and then they should curl toward the east. So suppose I stretch my right hand fingers along upward direction, means this direction like this, and east is in that direction according to the board. So can the right hand fingers naturally curl toward east? Yes, fingers are initially along the upward direction according to this sense, and then they are naturally able to curl toward the east. It means thumb will point in the direction of n cap or the resultant vector. So the resultant vector here according to this diagram should be along the north. Answer to this computation will be north. I hope you understand this. Take another example. Suppose I ask you north cross east. Give it a try. Stretch your right hand fingers along north, then they should be able to curl toward east. Right hand thumb will give you the direction of the n cap. Give it a try. Right hand thumb will give you this resultant direction. Okay, now I'll be taking few wrong orientations of the palm, and then I'll tell you the correct one. Suppose I put my palm like this. The fingers are stretching along the north. Now these fingers of right hand, can they naturally curl toward the east? Think about it. Is it possible? Fingers of right hand are along north. They should curl toward east. Is it feasible? It's not feasible for normal people. Okay. It means this orientation is wrong. Done? Now I am taking the correct orientation. Suppose I stretch my right hand fingers along north like this. Okay. Now from north, the fingers must be able to curl toward east. From north, the fingers are able to curl toward east. Then thumb, the right hand thumb is pointing inwards, and inwards direction we have taken as downwards. Do you get this? Taking up another example. Suppose I ask you downward cross south. You should be very precise in the pronunciation of these things. It is not into, it is cross. This is not A vector into B vector. It is A vector cross B vector. Okay. Now can you answer this? Downwards cross south. Use your right hand. Stretch your right hand fingers along downwards. They must be able to curl toward the south direction naturally. Then your right hand thumb will give you the direction of the resultant vector. Okay. Now I am doing the calculations. I am showing you the orientation. Down is perpendicular inside like this. So you will stretch your right hand fingers like this, let's say, toward the downward direction. Now can they naturally curl toward the south? Think about it. Right hand fingers are like this. Are they able to curl toward south? Not feasible. Suppose you put your right hand fingers like this along the downward direction, which is into the board. then can your right hand fingers naturally curl towards south? It means this orientation of palm is also wrong. Now I am going with the correct orientation of palm. Suppose my right hand fingers are along the downward direction as shown here into the board. Then they are able to naturally curl toward the south, and thumb is pointing along this direction, and this direction is west. So this must be the answer. I hope you all got the correct answers. I am taking one more question. Suppose you try this: west cross up. Give a quick answer. Stretch your right hand fingers along the west. They should be able to curl naturally toward the upward direction. Do it. I am directly taking the correct orientation of the hand. The west direction is here. So stretching the right hand fingers along the west, and up is towards you, perpendicular to the board in this direction. So first I am stretching the right hand fingers along west, and then they are curling towards up. Towards up means they are curling towards you, where the thumb is pointing. It means this answer must be north. You should note down all these things. I'll give you few similar questions in the checkpoint. There also you can practice. After you note down all these things, we'll be taking the important points regarding the cross product or vector product. Now we'll be taking up few important points about the vector product. The result of A vector cross B vector is a vector. You can see by the formula the direction is involved. There is some magnitude as well as the direction. So the result is always a vector. That's why we call it as vector product. Here are few examples. You will require these things in the chapter rigid body dynamics. Torque vector is equal to R vector cross F vector. The angular momentum vector will be equal to R vector cross P vector. P vector is indicating the linear momentum. So the result of the cross product is always a vector quantity. Second thing, A vector cross B vector is not equal to B vector cross A vector. Why? Because of the right hand rule. The direction of A vector cross B vector for this diagram was up, and the direction of B vector cross A vector was down. Getting it? So if someone asks you the direction of A vector cross B vector, it is like this, and direction of B vector cross A vector, it is like this. They are anti-parallel, making an angle of 180 degree. Okay, I'm explaining that again. The blue is the A vector and the red is the P vector. You do A vector cross B vector, stretch your right hand fingers along the blue one. They are naturally curling toward the B vector. So this is the direction of A vector cross B vector, upward. And now I am doing B vector cross A vector, stretching right hand fingers along the red one, the B vector, curling them toward the blue one, A vector. B vector cross A vector, thumb is pointing downwards. Getting it? So angle between them is 180 degree. That's why vectorially they are unequal. But the magnitude of A vector cross B vector is equal to the magnitude of B vector cross A vector, which is equal to AB sine theta. When you do A vector cross B vector or B vector cross A vector, you consider the angle between these two vectors as theta only, so their magnitude comes out to be same. Next important point, the magnitude of A vector cross B vector may be negative, 0 or positive. The theta can have various different values, and accordingly the sine theta can give you various different values, negative, 0 or positive. Okay, for example, suppose A vector and B vector are like this. How much is A vector cross B vector in this case? Think about it. Angle between them is 0. Sine 0 degree is 0. It means A vector cross B vector will result into a null vector. Another possibility, let's say this was the A vector and this is the B vector. They are collinear. Angle between them is 180 degree. How much is A vector cross B vector in this case? You will require here theta as 180 degree and sine 180 degree will again become 0. It means this will also result into a null vector. So whenever two vectors are parallel or anti-parallel, their cross product will always become 0. It's a nice trick. Suppose in 3 dimension they give you some vector. A vector is equal to something I cap, something j cap, something k cap, and B vector is also given, and you have to check whether they are parallel or not. You can do their cross product. If that cross product is becoming 0 vector, it means they are parallel or anti-parallel. Okay. Another possibility, suppose the A vector and B vector are perpendicular to each other, then you will get the maximum value of mod A vector cross B vector, which is equal to AB. Sine 90 degree will become 1. So the magnitude of the cross product will be maximum if the two vectors are perpendicular to each other. Okay. Next important thing, A vector cross A vector should be equal to how much? Look at this formula. The angle between both A vectors is 0 degree. They are in the same direction. So you will write this as A sine 0 degree and n cap. Sine 0 degree will result into 0. So the resultant is a 0 vector or null vector. This is also important thing in physics. If you do the self cross product of a vector, then answer will always be a null vector or 0 vector. Taking up the next important point, suppose someone asks us the value of I cap cross I cap. Utilizing this formula, what you will write? Magnitude of the first vector is 1. Magnitude of the second vector is also 1. Sine, how much is the angle between these two unit vectors which are directed along x-axis? Angle is 0 degree multiplied with the n cap. Sine 0 degree is 0. It means this result will be 0 vector or null vector. The resultant of the cross product will always be a vector. Getting it? Similarly, if I ask you j cap cross j cap, what you will say? 0 vector. K cap cross k cap, that will also be the 0 vector. Okay, same way you can simplify the things. Another important thing, if someone asks you I cap cross j cap, I cap is a unit vector along x-axis, j cap is a unit vector along y-axis. So using this formula, magnitude of the first vector is 1, magnitude of the second vector is also 1. Sine, what is the angle between these two unit vectors? One is along x-axis, other is along y-axis. Angle is 90 degree multiplied with the n cap. Now you need to determine the direction of n cap using which rule? The right hand thumb rule. If this is x-axis, we consider here I cap. If this is y-axis, we consider here j cap. Then where will be the z-axis? Z-axis will be perpendicular outwards. I cannot draw that here in the air, so I am showing that little bit inclined like this. Okay, and here is the unit vector k cap. This z-axis is actually coming out of the board like this. Now, if you use the right hand rule to determine the direction of the I cap cross J cap, stretch your right hand fingers along I cap. They should naturally curl towards J cap. Then thumb is pointing outward, and outward direction has been taken as K cap. It means the value of N cap here is actually K cap. Now check the final result. Sine 90 degrees also 1. So the ultimate result will be K cap. This is also important thing. I cap cross J cap is always equal to K cap. Next computation. J cap cross K cap. Think about it. 1 into 1 sine 90, and unit vector is directed in which direction? The N cap is directed in which direction? Use the right hand rule for J cap cross K cap. The answer will come out to be I cap. I am explaining that J cap is here and K cap is coming outwards like this toward you. Okay. So I'll be stretching my right hand fingers along the J cap first, and then they should naturally curl toward K cap. K cap is actually coming outwards. So thumb will point towards I cap. It means the direction of N cap will be along the I cap. Getting it? Next is K cap cross I cap. K cap cross I cap will be 1 into 1 sine 90 degree J cap. The final answer will be J cap. You can check it how you got the N cap as J cap. Got it, or shall I explain? I am doing that. You stretch your right hand fingers along K cap, and then they should be naturally curling towards the I cap. So K cap is coming out like this. Do you agree? So K cap is coming out like this, and I cap is in this direction. Now in this orientation, can my fingers naturally curl toward I cap? All fingers. It's not feasible for the normal people. It means this orientation of the hand is wrong. Let me try something else for K cap cross I cap. I stretch my right hand like this. This is the direction of K cap towards you. Then can these fingers naturally curl toward I cap? Is it feasible? Means this orientation is also wrong. Now I am taking the correct orientation. Stretching the right hand like this. The fingers are towards you, towards K cap. So this is K cap, and then they should curl toward I cap. This is the direction of I cap. So K cap cross I cap. Where thumb is pointing? In the J cap direction. It means this answer must be J cap. Got it? Taking up another thing. Suppose I ask you J cap cross I cap. Then can you tell me the result directly? We know that this magnitude will be 1. Can you tell me the direct result? J cap cross I cap. Stretch your right hand fingers along J cap. They should be able to naturally curl towards I cap. Then your thumb will point inward, and inward direction will be written as minus K cap. If the outward is plus K cap, then inward is minus K cap. I am again explaining that. Stretch your right hand fingers along J cap. They are curling towards I cap. Thumb will point inward. Inward is minus K cap. Okay. Any other orientation of the hand is wrong. Only this one was correct for J cap cross I cap. Okay. Next, K cap cross J cap. What should be an answer? K cap is coming out towards you. So this is the direction of K cap. I am stretching my right hand fingers along the K cap like this. Now they are able to curl directly towards the J cap. So K cap cross J cap. Thumb is pointing here, and this direction is minus I cap. So computation of this LHS will result into minus I cap. Magnitude will come out to be 1 only. Similarly, one more calculation we can do, I cap cross k cap. Think about it. I cap is in this direction and k cap is coming towards you. So I cap is in this direction and k cap is coming towards you. See, I cap cross k cap, thumb is pointing downwards. So this result is actually minus j cap. Okay, either you can compute them every time, or there is a nice trick for all these calculations. We draw a circle and then we put there I cap, j cap and k cap like this. Now you follow the orders, I cap cross j cap, I cap cross j cap, we are following the order, then result is k cap. Next, j cap cross k cap, we are following the order of the arrows, so the result will be I cap. Next, k cap cross I cap, k cap cross I cap, we are following the orders, so result will be j cap. When you go opposite to the order of the arrows, such as j cap cross I cap, j cap cross I cap is in the opposite way, so the resultant will be minus k cap. K cap cross j cap, k cap cross j cap, you are going in the opposite order of the arrows, so the result will be minus I cap. I cap cross k cap, I cap cross k cap, we are going in the opposite order, so the result should be minus j cap. It's a nice trick. Either you simplify everything or you can solve it like this. And if you complete the circle, I cap cross I cap, result will be 0 vector. J cap cross j cap, result will be 0 vector. K cap cross k cap, result will be 0 vector. It's a super trick. You can note down all these things, then we'll take up the remaining points on the next screen. We know that n cap is perpendicular to a vector as well as perpendicular to b vector. So the n cap dot a vector is equal to n cap dot b vector. What should be this result? It should be actually equal to 0. Whenever two vectors are perpendicular, their dot product is 0. And whenever two vectors are collinear, their cross product is 0. Remember it. Another thing, I can write n cap dot a vector plus b vector, or n cap dot a vector minus b vector. All these calculations will result into 0. Why? A vector plus b vector will be lying in the plane of the a vector and b vector itself. Let's say this is a vector, this is b vector. The resultant a vector plus b vector will be lying somewhere here, and n cap is perpendicular to that. Okay, so n cap dot a vector plus b vector will be 0. Similarly, n cap dot a vector minus b vector will also be 0. Taking up the next important point, suppose a vector is equal to axi cap plus ayj cap plus az k cap, and b vector is equal to bxi cap, byj cap, bz k cap, and we need to obtain the value of a vector cross b vector. It requires the knowledge of little bit mathematics. See how to operate it. You write here I cap, j cap and k cap. If here is the a vector first, it means you will put the components of a vector. So here will be ax, ay and az. Then here we have the b vector. So the components of the b vector you will put as bx, by, bz. Getting it? Whatever vector is written here at the first position, its component will be lying here. Whatever vector is written here at the second position, its component will be lying here. Then You write the things like this: I cap and a bracket minus j cap and a bracket plus k cap and a bracket. It's a trick. You need to learn it. Then we start in this direction and we try to finish like this. I'm explaining it. If you want to solve this bracket associated with the I cap, you hide the column and the row of the I cap, means you hide these things. Okay. Then you start like this. If you hide the column containing the I cap and the row containing the I cap and you start like this, what you can write? You can write AYBZ, then put a negative sign. Again, you need to operate along the blue arrow. What you will write now? AZBY. Do you get this? Now we are solving for J cap. You hide the column and the row containing the J cap and then start like. So what you should write? AXBZ, then put a negative sign. Now hide the column and the row containing the J cap and finish up like this along the blue arrow. Then what you should write? AZBX. Okay. Last part we are operating for K cap. Hide the row and the column containing the K cap and then start along the black arrow. What you should write? AXBY. Then there is a negative sign. And now what you should write? AYBX. This is the resultant of the A vector cross B vector. Okay. You can write it in another way as shown here: AYBZ minus AZBY multiplied with the I cap. And this minus sign I am taking inside. So it will be AZBX minus AXBZ. Do you agree? This minus sign has been taken inside. And here we have AXBY minus AYBX of K cap. Both are equal results. Whether we use this one or this one, choice is yours. Just you need to take care of all these components. Okay. Note it down. I'll illustrate it through few examples. Then you'll understand it better. Here is one more important result. We know that mod of A vector cross B vector is equal to AB sine theta. The magnitude of this cross product is this much. Okay. So sine theta can be written as mod of A vector cross B vector divided by AB, or the theta can be written as sine inverse of mod of A vector cross B vector divided by AB. The same things in few books will be represented as mod of A vector cross B vector, and this can be written as mod A vector and this can be written as mod B vector. So using this formula, we can find the angle between two vectors. Okay. Can you tell which one is easy? We had one formula for the angle in the dot product and we have one formula for the angle in the cross product. Which computation is better? Which is easy? Actually, finding the angle through the dot product is comparatively easy. So this is rarely used. Just for your knowledge purpose, you can note it down. Then we'll be taking a few more important points. Next important point, suppose we have A vector and B vector in a plane as shown, and we complete a triangle like this. If you need the area of the triangle, it should be equal to half modulus of A vector cross B vector. We have already seen how to solve the A vector cross B vector, and then we can easily take the modulus also. And if you complete a parallelogram, area of parallelogram will be equal to mod of A vector cross B vector. See the completion of parallelogram here. Can you shift A vector here like this? This will also be the A vector only. And can you shift the B vector here parallel? So that B vector will look like this. Now it's a complete parallelogram. Area of this parallelogram is actually the combination of area of two triangles. So if you know the area of this triangle, same area this triangle will also have. That's why this result. Okay. Another result. Suppose this parallelogram has this diagonal as the D1 vector, and this other diagonal of the parallelogram is indicated as D2 vector. Then the area of parallelogram will be equal to, you can just note down the formulas. Fine. Then we'll be taking up the questions. Here is the first illustrative question. We know the magnitude of two vectors. We know the magnitude of their cross product or vector product. We need to find the angle between these two vectors. You can pause and you can give it a try. I'm simplifying it here. It's a simple one question. We know that magnitude of A vector cross B vector is given as mod of A vector mod of B vector sine theta. Mod of A vector is given to us as 5 unit. Mod of B vector is given as 6 unit. Sine theta is unknown. And mod of A vector cross B vector is given as 15 unit. Getting it? So 5 and 15, you can write here 3. Sine theta will be left as 1 by 2. So theta will be equal to 30 degree. Pretty simple answer. Note it down. Then we'll be taking up question number 2. Here is the second question. If the mod of A vector cross B vector is root 3 times of A vector dot B vector, then we need to find the angle between these two vectors, the magnitude of A vector plus B vector and the magnitude of A vector minus B vector. You can pause and you can give it a try. Here theta is the angle between A vector and B vector. I am simplifying the things here. First of all, writing this data, magnitude of A vector cross B vector, we know that is written as AB sine theta is equal to root 3 magnitude of A vector dot B vector. We already know AB cos theta. Here AB and AB is getting cancelled out. So tan theta is equal to root 3. It indicates that theta should be 60 degree. Do you agree? If theta is 60 degree, we can simplify the second question and third question very easily. Magnitude of A vector plus B vector is given as root of A square plus B square plus 2AB cos theta. So it should be written as A square plus B square plus 2AB cos of 60 degree. Cos 60 degree is how much? 1 by 2. So this answer will be a square plus b square plus 2ab into 1 by 2. Ultimate result is a square plus b square plus ab. Done. Now I am simplifying the third part here. Mod of a vector minus b vector. Few smart students can tell me the result directly. Write your result in the comment box. It is a square plus b square minus 2ab cos theta. So it is root of a square plus b square minus 2ab cos of 60 degree. The value of cos 60 degree and this entire calculation we have already seen. So it is a square plus b square minus ab. This is the final result. I hope you understand this. Okay, simple question. Note it down. Then we'll be taking up the next one. This is also a simple question. You can post your answer in comment box. Similar question we have done earlier. I hope you all got the correct answer. Here the angle theta comes out to be 45 degree. Pretty simple calculation. Mod of a vector cross b vector is what? AB sine theta. A vector dot b vector is what? AB cos theta. AB and AB is getting cancelled out. So sine theta by cos theta is equal to 1. It means tan theta is equal to 1. Therefore, theta should be 45 degree. Clear? Simple one. Note it down. Then we'll be taking up the next one. Here is the next question. We are given the two diagonals of a parallelogram and we need the area of this parallelogram. I am simplifying it. You pay attention. We know that area of parallelogram is given as half modulus of d1 vector cross d2 vector. So basically we should first obtain this d1 vector cross d2 vector. d1 vector cross d2 vector can be solved using this method. Here is I cap, j cap, k cap. Since d1 is the first vector here, so I'll write its component here. 3, 1 and 2. Then d2 vector. This component is 1, this component is minus 3 and this component is 4. Do you agree? Now, for solving the d1 vector cross d2 vector, I should write here I cap and then should hide the row and the column of the I cap and multiply like this. So it will be 4. Okay, then there is a negative sign. Getting it? Then we'll be multiplying these things. So it will be minus 6. Do you remember? We start like this and then we return back on this path. I'm repeating it again. Hide the row and column of the I cap, then start like this. It will be 4. Then come back like this. So it will be minus 6. Then here we'll write minus j cap. It's due to the formula. Hide the row and column containing the j cap. Start like this. It is 3 into 4, 12. Then there is a negative sign. 2 into 1 is equal to 2. Done. Plus k cap. For solving this part, hide the row and column containing the k cap and start like this. 3 into minus 3 is minus 9. And then minus 1 into 1. Getting it? Simplifying it further, 10 I cap minus 10 j cap minus 10 k cap. This is d1 vector cross d2 vector. I hope you understand this computation. Now, taking the magnitude of d1 vector cross d2 vector. You know how to take up the magnitude. It is root of I cap coefficient square plus j cap coefficient square plus k cap coefficient square. So this is actually equal to 10 root 3. Now you have to submit the value here. It is half into 10 root 3. So the answer is 5 root 3 unit. Okay, pretty simple question. Note it down. And now you'll be getting a checkpoint. You should pause there and you should try all the questions yourself. Answers of all these questions can be verified at the end of this video. Now taking up the last topic of this video, the division of vectors. Actually, division of vectors is not permissible in physics. Why? Let's see it here. Suppose we have F1 force as 5 Newton along north direction. We have F2 force 2 Newton along east direction. And if you wish to operate F1 vector by F2 vector, you can divide these two magnitudes. Okay, 5 by 2 will give you 2.5. But north by east, is it of some use to us? Think about it. Have you ever defined such thing anywhere? North by east. It means this kind of division is not permissible in physics. Okay, can you define the multiplication of directions? Northeast, southwest? Yes, multiplication is feasible. Addition of vectors is feasible. Subtraction of vector is feasible. Multiplication of a scalar and vector is feasible. But division of two vectors is not possible. Getting my point? Fine. Note it down. Then you will get answers of all the checkpoints. This topic is over from my side. Stay awesome. Take care.